In this closer look, we'll focus on converting from moles to particles. As a reminder, a mole is a really big number, 6.02 times 10 to the 23rd, sometimes referred to as Avogadro's number. The particles in the conversions can be either atoms or molecules. When doing these calculations, use this conversion factor. The numerator in the conversion factor is 6.02 times 10 to the 23rd, which could be atoms, molecules, or formula units, and the denominator is 1 mole of the substance we are converting. When doing conversions problems, remember, take the number you are given in the problem and put it in the upper left-hand corner of the conversion chart. For this problem, there are 3.51 moles of sodium given. The next step is to bring the units down, so put moles of sodium in the denominator of the second column. And 1 mole of sodium is the same as 6.02 times 10 to the 23rd sodium atoms, so I will write that in the numerator. Notice that the units of moles of sodium cancel, leaving atoms of sodium, which is what you are solving for. All that's left to do is to multiply 3.51 times 6.02 times 10 to the 23rd. If there are numbers other than 1 in the denominator, divide those numbers, but in this problem there is only a 1. So 3.51 times 6.02 times 10 to the 23rd will give us the number of sodium atoms, and the result is 2.11 times 10 to the 24th. That's how many atoms of sodium there are in 3.51 moles of sodium. This next problem involves converting from moles to molecules of water. How many molecules of water are there in 2.75 moles of water? Since molecules are very small, they are considered representative particles, so solve this problem in a similar way to the last one. Take what's given, 2.75 moles of water, put that in the upper left-hand corner of the conversion chart, bring down the unit, moles of water in the denominator of the second column, and 1 mole of water is the same thing as 6.02 times 10 to the 23rd molecules of water. Again, notice the moles of water cancel, because they appear in both the numerator and the denominator. The unit that is left is molecules of water, which is what you're solving for. So all that is left to do to get the answer in molecules of water is to multiply 2.75 times 6.02 times 10 to the 23rd. And when 2.75 is multiplied by 6.02 times 10 to the 23rd, you get 1.66 times 10 to the 24th molecules of water. That's the same thing as 2.75 moles of water, and that is the answer you are looking for when converting moles of water to particles of water. Here's one for you to try. How many molecules of carbon dioxide are there in a sample of 0.75 moles of carbon dioxide? When you're ready, press pause, try to solve the problem, and when you think you have it, press play and check your answer. Let's see if you got it right. This is how your setup should have looked. 0.75 moles of carbon dioxide placed in the upper left-hand corner. Then you should have brought the units down to convert from the moles of carbon dioxide to molecules of carbon dioxide. The units cancel because they appear in the numerator and the denominator, so moles of carbon dioxide go away. And all that is left to do is multiply 0.75 times 6.02 times 10 to the 23rd to determine how many molecules of carbon dioxide there are. And when you multiply those two together, you get 4.5 times 10 to the 23rd molecules of carbon dioxide. That is the same amount of carbon dioxide you have in 0.75 moles of carbon dioxide. So you converted that into molecules. That's a closer look at converting moles to particles. For more chemistry matters, go to our homepage, where the entire series is available to you.